Now we will find the field log regions that can become behavior model input. The best source is usually a commissioning log or a first running time log. It should include normal startup, stable running, and shutdown. If available, it can also include power interruption or fault events. The new workflow starts in behavior setup. Instead of manually cutting the raw log first, we let the machine log candidate builder scan the raw CSV files, find possible startup, running, shutdown, and fault regions, and give each region a score. The candidate builder does not make the final behavior model by itself. It finds evidence candidates. The engineer still reviews the trends before importing anything.
Before saving candidate outputs, confirm the compressor type in the Behavior Curve Editor area. The save commands use the selected compressor type to suggest TT underscore or VT underscore file names. Press Folder and select the folder that contains the raw machine logs. The scanner reads CSV files in that folder and its subfolders. Press Scan Logs. ModbusSim looks for compressor data blocks. The important columns are compressor state, demand actual or demand requested, RPM, power, and fault indicators. If a file does not contain enough compressor columns, it is skipped. When the scan is complete, the best candidate regions appear at the top of the table.
The table is the first quality filter. Each row is one proposed region from one source file. The main columns are Use, which marks the row for merged CSV export, Score, which ranks the candidate, Role, such as running table, startup, shutdown, or power loss, File, which shows the source CSV, Comp, which shows the compressor number, for example C1 or C2, Rows, demand, RPM, and time, Quality, which summarizes running percentage, fault percentage, stage changes, and jumps, Notes, which lists warnings. The score is useful, but it is not automatic approval. A high score means the region is worth reviewing. The visual trend still decides whether the CSV is credible behavior evidence.
For a running table candidate, we want normal running rows. The demand range should be as broad as the real log allows. RPM, power, pressures, temperatures, and superheats should move in a believable direction as demand changes. For a startup candidate, we want one clean transition from stop to running. It should not include a long unrelated idle period or several repeated start attempts. For a shutdown candidate, we want one clean transition from running to stopped. It should not include unrelated running time before the stop sequence or a new staging event immediately after the stop. For a power loss or fault candidate, the fault rows are intentional. Do not mix those rows into the normal running table unless the support case is specifically about fault behavior.
Use the quality and notes columns to reject weak regions before opening every trend. Warnings such as narrow demand range, missing low demand, or missing high demand do not always reject a candidate. They tell us what the field log does not cover and what may need engineering-approved anchors later. Warnings such as other compressor staging, jumpy demand/RPM, repeated cycling, or fault rows in a normal table candidate are stronger rejection signals. In a multi-compressor chiller, another compressor starting or stopping can move pressures, temperatures, demand, and RPM in a way that does not belong to the selected compressor behavior model. The goal is not to keep the most rows. The goal is to keep the cleanest rows that explain one useful behavior state. Select a promising candidate row and press Open Trend. This opens Open Trend of selected CSV. ModbusSim loads the original source CSV, uses the compressor number from the selected candidate, and selects the candidate's time range. This is the important review step. The candidate builder found a possible region. The trend estimate tells us whether the region is actually good enough. The trend estimate shows the selected file, row count, trend column count, compressor number, role, and x-axis. For a running table, the x-axis should normally be demand. This makes it easy to check whether RPM, power, pressure, temperature, superheat, and electrical values move in a believable direction as demand changes. For startup, shutdown, power loss, and fault candidates, the x-axis normally uses seconds. This makes it easier to inspect the event sequence from beginning to end. Use defaults to select the common trends, or select trend groups manually. Demand and RPM are usually the first two signals to check. Then add power, pressures, temperatures, superheats, voltage, current, DC bus, and fault signals as needed. Use the overlap trend, X window, zoom buttons, and region sliders to focus the useful part of the source log. A good running candidate has readable curves, a clear demand range, and values that move smoothly enough to become training evidence. RPM and actual power should follow demand without heavy vertical bands, repeated cycling, or unrelated staging behavior. A good startup candidate shows one clean rise from stop toward running. A good shutdown candidate shows one clean decay from running toward stopped. A poor candidate has repeated vertical bands, jumps, heavy oscillation at the same demand level, mixed states, staging transitions, or fault rows that do not belong to the role. When the preview shows poor CSV quality, do not continue just because the file can be loaded. Select another candidate, choose a smaller selected region, or request a cleaner machine log from the service technician.
At this point, do not explain every file name pattern. The viewer only needs the rule. If one candidate is clearly good, save it as accepted evidence for its role. If several candidates should be combined, check the useful rows, build the checked output, then review the result before import. Candidate outputs are review material. Final import files must use the role suffixes already mentioned in the recording rules. Anything still marked as a candidate should be reviewed again or resaved as accepted evidence before it is imported.
In Open Trend of selected CSV, use the region sliders to narrow the accepted range. Use Save Region CSV when the selected source region is good and only needs to be saved for import. Use Clean Noise CSV only when the region is valid but has small analog spikes or noisy repeated samples. Demand and discrete or status columns are preserved, analog columns are cleaned with guarded smoothing and median spike removal. Do not clean away a real event. If a pressure jump, RPM change, or fault transition is real behavior, keep it or choose a different region. After saving a clean file, open it again and review the trend before accepting it. Use Save PDF only when an offline quality review is useful. This is helpful when another engineer or service technician needs to understand why one candidate was accepted and another was rejected. Before importing, do one last roll check. Check that each accepted file contains the correct behavior, startup file, one clean rise from stop toward running. Running file, normal running points with useful demand and RPM behavior. Shut.swn file, one clean decay from running toward stopped. Power loss file, only the intended fault or power interruption event. Also check that you did not include staging transitions from another compressor, repeated cycles, unrelated faults, or long extra sections. The first import should give easy initial anchors. It does not need to be perfect, but it should be clean enough that the engineer can see the real shape before adding approved points. Manual Excel trimming is still acceptable for unusual logs, but it is now a fallback. Start with the candidate builder and open CSV estimate because they keep the scan, trend review, selected region, and accepted output in the same workflow.
The accepted evidence is now ready for import. It does not replace the original field log. It is a clean role-specific extract that passed a visual trend estimate. Because we checked the candidate score, the notes, the demand and RPM shape, and the selected trend region first, the import should create simpler initial anchors and fewer confusing repeated points. Next, we will select the compressor identity in ModbusSim and import the accepted evidence.